Now today we will take a look at the second chapter. The second chapter for our course would be about networking. It's called a connected world. A connected world. And there we'll take a look at something related to internet, and then we'll explore what is intranet, extranet, and that basically something we will cover in this chapter. If we take a look at the If we take a look at the learning objectives here, we can find out for internet it would have around this area here. We have to know what is internet. We have to know about internet different services there. All right, that's something that we talk about. All right, it's internet and internet services. And then the second part will be this one, intra and extra. This is about how companies use them for productivity. And the last part would be about the major development, and it's actually concentrating on something that people always say in today's world, IoE, Internet of Things, or IoT, Internet of Things or Internet of Everything, sorry, IoE and IoT. By the end of this class here, we're gonna have a much clearer concept about it. If you can still remember, in IT there, we say internet is an IT, is a tool. It's actually like wire, W-I-R-E, wire. It's like wire. It helps you to connect one part or something or one company or individual to another, just like a mobile phone, right? Mobile phone is not something that we use to connect, but the radio wave that helps us connect, right? So internet is something like that. It's the wire, right? It's the wire. We have to know it pretty well right now because we know from chapter 1 that this internet is getting more and more important in our life, and we are more and more dependent on it, right? So the business world that we are running also share the same phenomenon. Now, before we talk about the details of internet, I wish to show you a short video about the development of it first. It's not a very new video, it's rather old actually, but the history about it is actually quite fixed, and that's why it's no harm that we actually take a look at that first. So let me stop this slideshow first and then turn to the video, which is actually on YouTube. Let me end the slideshow first, and then I show you this video here. Right, it's the history of the internet. Right, is here. Right. Okay, let's see.
The Internet in the year 2009. We send emails, make calls over the Internet, and discuss topics we take an interest in. Even our banking is going virtual. But what we take for granted today was only a vague idea 50 years ago. In order to understand how we got this far, let's go back to 1957, when everything began. Before 1957, computers only worked on one task at a time. This is called batch processing. Of course, this was quite ineffective. With computers getting bigger and bigger, they had to be stored in special cooled rooms. But then the developers couldn't work directly on the computers anymore. Specialists had to be called in to connect them. Programming at that time meant a lot of manual work, and the indirect connection to the computers led to a lot of bugs, wasting time and fraying the developers' nerves. The year 1957 marked a big change. A remote connection had to be installed so that the developers could work directly on the computers. At the same time, the idea of time sharing came up. This is the first concept in computer technology to share the processing power of one computer with multiple users. On October 4th in 1957, during the Cold War, the first unmanned satellite Sputnik 1 was sent into orbit by the Soviet Union. The fear of a missile gap emerged. In order to secure America's lead in technology, the US founded the Defense Advanced Research Project Agency in February 1958. At that time, knowledge was only transferred by people. The DARPA planned a large-scale computer network in order to accelerate knowledge transfer and avoid the doubling up of already existing research. This network would become the ARPANET. Furthermore, 3 other concepts were to be developed which are fundamental for the history of the Internet. The concept of a military network by the RAND Corporation in America. The commercial network of the National Physical Laboratory in England. And the scientific network Cyclades in France. The scientific, military, and commercial approaches of these concepts are the foundations for our modern Internet.
Pay attention on this part here. This is also something that mentioned in our notes. This is the foundation here. ARPANET, NPL, Cyclades, all right, and RAN, basically. If you see Internet is a tree, tree is actually grow from, if this is an apple tree, this go from apple seed, right? So this is the seed, right? Now, once the tree grown up, no longer that we see the seed exist, and that's why these network basically also disappear, but they start, right, at the very beginning, from academic, from defense department, all right, and from commercial field in the UK. All right, let's carry on.
Let's begin with the ARPANET, the most familiar of these networks. Its development began in 1966. Universities were generally quite cautious about sharing their computers. Therefore, small computers were put in front of the mainframe. This computer, the interface message processor, took over control of the network activities, while the mainframe was only in charge of the initialization of programs and data files. At the same time, the IMP also served as interface for the mainframe. Since only the IMPs were interconnected in a network, this was also called IMP subnet. For the first connections between the computers, the Network Working Group developed the Network Control Protocol. Later on, the NCP was replaced by the more efficient Transmission Control Protocol. The specific feature of the TCP is the verification of the file transfer. Let's take a short detour to England. Since the NPL network was designed on a commercial basis, a lot of users and file transfer were expected. In order to avoid congestion of the lines, the sent files were divided into smaller packets, which were put together again at the receiver. Packet switching was born. In 1962, American Ferret aircraft discovered middle and long-range missiles in Cuba, which were able to reach the United States. This stoked fear of an atomic conflict. At that time, information systems had a centralized network architecture. To avoid a breakdown during an attack, a decentralized network architecture had to be developed, which, in case of loss of a node, would still be operative. Communication still used to work through radio waves. That would have caused problems in case of an atomic attack. The ionosphere would be affected and the long-wave radio waves wouldn't work anymore. Therefore, they had to use direct waves, which, however, don't have a long range. A better solution was the model of a distributed network. Thus, long distances could be covered with a minimum of interference. Another milestone followed with the development of the French network Cyclades. Since Cyclades had a far smaller budget than ARPANET, and thus also fewer nodes, the focus was laid on the communication with other networks. In this way, the term Internet was born. Moreover, Soclades' concept went further than ARPA's and the MPL's. During communication between sender and receiver, the computers were not to intervene anymore, but simply serve as a transfer node. Soclades' protocol went through all machines using a physical layer that was implemented into the hardware, providing a direct connection with the receiver, an end-to-end structure. Inspired by the Soclades network and driven by the incompatibility between the networks, their connection gained in importance everywhere. The phone companies developed the X.25 protocol, which enabled communication through their servers, in exchange for a monthly basic charge, of course. DARPA's transmission control protocol was to connect the computers through gateways. And the International Organization for Standardization designed the OSI reference model. The innovation of OSI was the attempt to standardize the network from its ends and the channel's division into separate layers. Finally, the TCP assimilated the preferences of the OSI reference model and gave way to the TCP/IP protocol, a standard which guaranteed compatibility between networks and finally merged them, creating the Internet. By February the 28th, 1990, the ARPANET hardware was removed, but the Internet was up and running.
All right, now that's the video, and it summarized the working of the Internet that we are going to cover in this chapter. And that's why it's a good idea to start at the very beginning, right? And if we take a look at this one here, the Internet, and well, before I go on to the notes here, let me show you one more thing first. All right, I end the slideshow first. Right. Now, if you say in your computer that, for example, this is my computer, you can also kind of do something like that in your computer. If you want to know whether your computer is really hooked up online and communicatable with the others, you can consider right here and check typing ipconfig. Now let me make it bigger for you to see. Hang on. Let me make it maybe bigger for the cursor size. Oh no, sorry. For the font size should be. Because normally it's rather small. Yeah, right. That's the one. Yeah, right. In a poem like that, this is called a command point. In whatever system, right, they always actually had a way that you can control it directly using some text. No image, no sound, just text. That's the old way of controlling a system. But it always shows you whether you really have the Internet tray. Whenever we have a poem like that and type ipconfig, we're going to find out we have a lot of things that we don't know, but something that is also quite familiar to us, because we always mention this, IP. This is the evidence that a machine has gone online. Even this is a mobile phone, if this is able to be used and dialed to someone else, it actually also has an IP address. All right. Now this number is a unique number. Every time you get online to the Internet to communicate with the others, you have it. So that 172.28.2.110 is you. In the whole world, you have this number. Can I have 172.28.2.110? No. If this is the case, that means an IP clash. All right? Then I have to take another one for sure. All right? So this is kind of the key evidence. Now, once you have a computer with this IP, whatever it is, you'll be able to communicate because people can find you and you can find the others also. All right? Just that we don't like to get ourselves memorize this clumsy number. which is similar in the real world that I have a telephone here, people tell me about the phone number, and then I immediately use the name to substitute that person. For example, that person's called John, and he told me the number, and I just save it down, and then next time I'll just load up and search for John, and then I phone John right away. And at the same time, I forget about John's number. John, therefore, is what we use in the real human world. We normally call this domain, right? Well, a very popular domain in the internet world, of course, maybe something that you heard of, like Google, like Yahoo. Now, this is a computer with internet able. We call it internet able. That means it already has an IP. If it want to connect to another computer with the IP, okay, maybe I call them by the domain name. We normally do it that way. For example, ping yahoo.com. What I'm doing right now is I'm talking to Yahoo. I'm just like you pick up the phone and dial someone else. And this time I'm dialing Yahoo server. And immediately Yahoo responds to me, you see? You see this reply here from Yahoo. Yahoo is now in 74.6, as you see here. 74.6, 143, and 28. And this is the number no one can have but Yahoo only as well. Of course, this kind of communication is something that you never like to see, because this is actually something happening on the line of communication of the internet. But this shows you the evidence of internet, and this actually gives you a pretty good idea of the uniqueness of internet to most people in the world. Right? So in the internet, in a brief summary on that, it's actually a world of numbers. Everybody get a number, unique number, just like an ID. All right. Now, when you are internet ready, it does not mean that you have to really go to the browser and use it. Even though a lot of the time when we go for the internet, the first thing we'll be using is what? Is the internet browser. Browser is only one service on the internet. If I'm not using the browser, just as you see earlier, I can use a command terminal to communicate with the other, even though it is very primitive. I can use WeChat, WhatsApp. They have another way of communication, which is actually not a browser, but another interface. I can use the web, I can use the mobile, right? Or I can use the microwave, right? Browser, things like that, right? Okay, so this is the concept that we have to share. That's why we say internet is the line, right, of communication. Simply put, it's like that. And we sometimes call it internet because it's one network joining another. That's why it's network of networks. That's something you have to have in mind. But that network is like a big tree. It's not come up to the world empty from nowhere. It has actually an origin. If you can still remember the video we just see, that origin is the seed of internet. I wonder how many of you here been watch an animation in Japan called Sword Art Online. something, SAO, right? Something like that, yeah. And it's actually have the similar concept of a seed, yeah? You have a world and then you branch that out of a seed. If you have no idea about what it is, you're going to watch it later because it's on the internet actually. Even on Netflix, they have actually all the episodes put there. It's quite a good animation made recently in Japan, I would say. And internet seed actually is the origin. We have 4 mentioned in the video. Is ARPANET, as seen here. ARPANET actually is an academic network. In the very old days, that's 1957, 1960 actually, they only got about maybe 3-4 computers connecting to one another using a very secure, very safe way to do it. And that's the ARPANET. And later, the English set up NPL, remember, in the movie, right? And also the France commercial companies set up secretariats, and the US military set up RAND, R-A-N-D, RAND, so that they are forming the four basic seeds of internet, right? Remove that, please. And those things now disappear, just like the apples grown as a tree and the apple seed disappear, right? They are the backbone of the internet. They're the backbone. But the backbone now becomes the tree, then the backbone basically also kind of disappear, merge, right? Now, the backbone of the internet has a feature that it has very fast connection. And most of the connection there will be in fiber optics cables. We say fiber optics is fast. And do you know what fiber optics is? Anyone here in this room know what fiber optics is? Hong Kong, very famous of fiber optics because the past Hong Kong Chinese University of Hong Kong Vice President is Goh Kun, right? You heard of his name, Gao Kun. He is actually the founder. We call him the founder of fiber optics. But what is fiber optics? We have fiber optics in this room here. I'm telling you. What is something that? This is fiber optics, glass. Fiber optic is nothing but glass. Okay, glass. People just make the glass so thin, just like hair, which I don't have anyway. Right? Thin as hair, right? And then use it to communicate. All right? Fiber optics is glass. All right? The features of fiber optics is had a lot of internal reflection, right? So the light travel in it. If you study physics before, you know the faster things travel in the world is light. Is every second it travels 3 times 10 to the power 8 meter per second, right? It's really, really fast, right? And that's why it can carry a lot of data. When you can carry a lot of data, we say this is high bandwidth. High bandwidth means in 1 second it can carry a lot of things. Just like it's a very big card. You have a trolley card, right? But this trolley card is super big. In 1 second it carries a lot of things for you. Hong Kong is considered one of the very spectacular cities in a way that you have to know. Because in our whole city outside there, we basically have all those glass winding us together, just like the vessel in our body. And that's why we can have information flow in our city so fast. And one of the good thing about fiber optic is it let the data flow fast in it. But if you touch that glass here, you're going to find out it's very hard. It's also the bad point about fiber optic is once the line is set up, it's fixed. That means if I have a straight line of fiber optic and if I want to bend it, it breaks. And then you have to set up another line. So it's very expensive in a way that every time you want to change its shape, you have to set up a new one. And that's why it's so expensive. You see what I mean? Fiber optic 咧一屈就斷㗎啦，glass 就係脆㗎嘛，所以咧你一轉彎要整個房咧，你要再鋪過啦。So every time you change the ventilation in the room, you definitely have to get all the fiber optics installed again, and the installation cost is huge, actually. That's why not many cities can afford it, because that's actually a huge amount of money expense in the city. But Hong Kong is so rich that people here can afford it. Another place people can afford it is Tokyo. Not the whole Japan had fiber optic, I'm telling you, but only Tokyo, a small part of it. London, New York, some part of it. Most of the places in the world, when they communicate online, they're not using fiber optic, actually. They use copper wire. This is copper wire, something like that, which is bendable, but which carry a lot less information inside. In other words, low bandwidth, okay? So make sure you know it. Apart from that, we also need a lot of router. So what is router? People always say about router or router in English. So what is router or router? Router, you can put it that way. It's like a, we don't have it here, universal plug. Um, if you have a lot of electrical equipment, you have to branch it out, and that's a universal plug. So you can plug on it and share the electricity. And in Cantonese, it's 拖板, just like a 拖板, right? That's a router. So it's allow you to branch to wherever you like, right? It's a very convenient way of doing that. And you need them. And also we need some access point. Access point is the wireless router, basically, wireless router. You take a look at the ceiling up there, I think you also find one there. You take a look at the ceiling intendedly, yeah, over there, you found one. I think this room may have one or two. This is the NAP, the network access point. Basically, it's the wireless router. And that's why we can go wireless. When we say wireless, it's not really that we don't use a medium of transfer for the data, just that we, by that time, make use of radio wave to do it. If you have experience listening to radio wave, you're going to know what it is. As we said earlier, if every time we go online, we have to make use of the text mode, nobody going to use internet because you have to learn a lot of the buzzword before you can use it, and that would be really, really troublesome, isn't it? And that's why people in Europe, it's actually called CERN, CERN, they create something called World Wide Web. World Wide Web is an interface. This is a place, this is actually a medium, right? A presentation method, I should say, a presentation method with text, with sound, with picture, with movies put there. So that internet thing's gonna become very lively over there. If without the World Wide Web, we never use internet. The key features of World Wide Web, of course, is it have hypermedia. That means you have audio, text, picture, video, all those stuff there. Apart from that, it also have a lot of links, which branch out just like our brain. Maybe you're reading something about, say, I'm reading a commentary of a movie, and that movie mentions something of, say, Australia, and suddenly you want to know more about Australia. That's our mind go from one particular article to another. We call it radiating. Now, this World Wide Web is just like our mind. We can always branch in such a wild way, and that's why we don't have to really learn it because our brain operate this way. So even very old people, they know how to browse the web pretty quickly, efficiently, no learning time nearly. And that's why World Wide Web is a very important surface. Remember, we call this surface. SERVIC, surface on the internet, right? When we say surface, that means you may use it, you may choose not to use it, right? You may choose using the text I just shown you earlier. This is also the same thing. You're still onlining, all right? You're still interneting. Just that no one likes being like that. Unless you study computer science, you probably would have a higher interest using something like that. Now, another concept is also quite popularly used on the internet. You have to know this is actually the relationship of machine, server, and client. Now, why do you use internet? If you can still remember the video we just showed, internet exists because of this word here. Because we need to share something. 我哋要分享啲嘢，開心 share, alright? We have to share something, and that's why we go for internet. If never that you have that intention in the mind, never that you need internet at all, alright? So the sharing needs drives internet prosperity. You can put it that way. Okay, so if we have a big machine allowing us to share, we call this one a server. So a server have a features that let a lot of people share something in it. Technically speaking, what is a server? If you have two computers or more able to access a machine at one time, able to communicate with the machine at one time, it is a server. All right? In other words, if you run out of data, I turn on my hotspot and then I go online and you go through my telephone and then you go online as well. My telephone is a server because I have two people using the same machine at the same time. That's the definition of server. All right? Just that most of the time we know the server will be used by a lot of people. All right? So we used to think that server is big computer. But no, this is actually a relative concept. You can always turn this one into a server when you turn on the hotspot. All right? Now, if I use this particular machine to share with some people, one or two or three or four, no, more than two, I should say, two or more, and I only let those people see web pages, I call it web server. If I share with two or three people, I let them to see email only. This is an email server. And if I share with the others and I let them to see data only, that's going to be a database server. In other words, depending on what you're sharing, you're going to name that particular sharing machines the things that they share, and that's why we have the word. So these words are telling you what they're sharing. What can we share? We share web pages, we share data, we share program. You're going to experience that very soon. In your second semester, you go to a particular website, use that particular web pages to do the add and drop. You're sharing actually an add and drop program in the school. And that's what we call an application. An application is a software that's sharing on the internet. And it's normally like the web pages, but you have a lot of buttons to click. Just like the pages you use in library that you have something to click and then submit, things like that, right? All right, if you understand server, clients comes natural to you. So clients never share anything. They just get, all right? So they always get, right? They get only. They get what they want. I want to see the website, I get the page down, all right? I want to listen to the music, I get the audio file down. I want to watch that movie, I get the movie down, maybe bit by bit, like the YouTube stuff. So client is one computer using that particular machine at one time. All right. Most important thing always is don't think this is a fix, right? Because it's a relative concept. We can always change the machine we use to be a server or not server. Even the machine I'm using right now or the machine you're using at home, as long as you share with the other two people or three or four or more can use at one time, there's a server immediately. All right. Now, as we see earlier, we have some numbers here, right? If you can still remember, I showed you the command line. I go online because I have some numbers like that. Those numbers is what we call IP, Internet Protocol. This is the number used by machine to find you, all right? Just like our Hong Kong ID card has some numbers, it is not read by you and me or the policeman. No, it's actually read by the computer in the immigration department to identify you. You come here as a student. In HKCC, you have a student ID. That ID, again, is not used by the school. It's also used by the database in school, actually, to identify you. All right? So, as you see here, all those numbers, we call them actually, how how do we call this, registration number or register number, they're normally not very easy to remember. Even the telephone is actually that kind of things. And therefore, we always like to map this one with a name that we like, right? With a name that we know in the real world so that we can remember it better. That's the concept of domain. So domain is the number that we want to remember, but we don't want to remember it because it's too hard for us to remember it. So we make use of something that we can make sense of and remember better. If I have to remember someone that I know in the real world I call John, it's going to be much better than I have to remember his number of 20877 as see here in blue, 188, 166, because in no time I forget right away. But if I say John, or John Chan, or John Wu, whatever, I'll surely be able to remember it. And that's why this is the English unique name. It's still unique to us, right? But not to the computer, right? So we use the name, some of the name we use in the world we call domain name, and map it with the machine code, right? To do the mapping, we need a computer helping us doing that, and that would be actually another server. We call that domain name system server, DNS. DNS is nothing but to map the number with the name that we used. So every time, no longer than I have to type 10877.188.1.6, or for the Yahoo case, I don't have to remember the 74 something IP address. Rather, I just say yahoo.com, I got the computer location right away and communicate with that particular computer immediately, all right? So that is domain name system. Therefore, you see domain name is the way to convert name and IP to and fro, all right? Now here comes something that you may have some query in the mind. This is a big word. If you can remember the video we just showed you, we also mentioned something like that. Protocol. Protocol used in communication, right? If you want to translate this word into Cantonese, is hip thing. But even you know that Cantonese name, you never make sense out of it. So a better way of understanding protocol is the communications style, things like that. A very classic example for protocol use. Protocol is actually not used only in machine. It's used also between humans, right? In human society. When we go outside there and cross a road, when you see the red man, will you cross the road? No, because if there is policeman there, you get fined right away of dangerous road crossing, right? So red man standing, green man walking, that's a protocol. And of course, some people ignore it. I ignore it sometimes because I just take a look at the car and no car there, I would go. There's another protocol. There's the protocol in countryside. When I see no danger, I think it's safe. There's another protocol. So that's the way of working. Way of working. To communicate among the others, we have some way of working. So we put the number that way. That's why they have some route that we have to follow. And then people will understand this is the number of your machine. This is the location of it, right? Even you write your own address, there's a protocol. You write the room, the floor, the housing estate, the region, and then what? The country. That's the protocol also. If you write in a very chaotic way, the postman will get lost and cannot deliver your message easily, right? So, in order to let you and me communicate better, we set up some rules, especially in machine. Then the communication will be very precise, accurate, and we will not have any undesired silly things happen in between two, right? That's protocol. So, therefore, when we talk about network, you see a lot of the protocol there, all right? One more thing is protocols can sometimes be regarded as a language, all right? We speak the same language, we know one another pretty well, all right? I speak Cantonese, you speak Japanese, we can't communicate basically. because of wrong protocol also. Yeah. So we see it that way. Now, in this chapter here, we spend a lot of time. We spend a lot of time investigating World Wide Web because World Wide Web nearly be the most dominating surface on the internet. We actually have a lot of other surfaces. If you flip the pages down, you're gonna find out we actually have all those services as well. So World Wide Web is only one. And you're going to find out that World Wide Web is also the first service engulfing, that means it's actually eating other service, put it in them, all right? Like that. But we talk about this later. Let's come back to World Wide Web first. World Wide Web, therefore, you see is very important because it's very dominating, all right? That's why people sometimes think if I get World Wide Web, I go online. Well, this is actually a misconception because you know, when you use World Wide Web, that implies that you have a lot of communication, so you're internet ready. But when I say you internet ready, it doesn't mean that you must use World Wide Web. Can you see the difference? I say the sentence again. I use World Wide Web is implied I'm internet ready. That means I'm already using internet. But when I say I'm internet ready, it's not necessary that I use World Wide Web because World Wide Web is only one of the service available there, even though it's a very important one. To try to locate World Wide Web, we need to use something called website to get it. That website is called Uniform Resource Locator. So it's how you locate something. Now, because that locator is very important, so we try to make this locator more meaningful to us by setting some special rules for the domain. We set top level domain on it. So when we take a glance of those web pages, we more or less know where this website from because it has country information stored in it. If this is from Hong Kong, you see that website would end with HK. If this is from Japan, it ends with JP. If this is from the UK, you see this is end with UK. And if this is from China, you see it's end with CN, right? Those are the geographical location. And also we can see a particular website with what type of organization or company it is, right? If this is COM, that would more or less be a company. If this is ORG, that would be a non-profit making company. Most of the time it's like that. If this is EDU, and that would be education unit. Now, getting ourselves know all those set up becomes the common sense of modern man, and that's why we have to introduce you, and we call that generic. Generic means common TLD. For example, we know, as you see here, COM is company, EDU is education unit. Now, international organization, the old days use this one, but fewer and fewer people use it, is INT. Military in the world still use it, but if you're not keen on military development, you never realize this is actually a very common thing there. And government in the world today still use GOV from time to time to signify them over the internet. And net is normally for telephone houses, network company to get you online, right? ORG is non-profit. All right, GTRD. Try to get yourself remember a few of them, all right? Because now all those things becomes a common knowledge, common sense, general knowledge of the people around the world, right? And when you have to break down a URL, when we have a URL, we break it down. The first thing we can see is on the internet, whenever we transmit anything, right, just like when you talk to the others, you make sure what people he is. Oh, he is from Africa, so I have to use African language to talk with that guy. Oh, she is from Brazil, so I have to use Spanish to talk to her. Now I'm talking the language of web, so I'm using HTTP protocol, the rule of the World Wide Web. All right, so you have to tune in to the different person. What are you talking about? What kind of languages? What kind of style you're now using to communicate with the other. You set it up first. And then you have to locate where the computer is. In this case, this is the location of your computer. www.scub.edu. www of course means World Wide Web, but it is optional now. In the older day, we have to specify if this is World Wide Web or Telnet because we have a lot of things actually put on the World Wide Web. Now, this has become optional. But csu.edu is what? Is the IP turned into domain, actually. So if I know the IP there, I can replace csub.edu with the bunch of number that you know, actually. So by knowing that csub.edu, this is the machine location. You know where the machine is physically, right? Precisely. Every time you are reading something, getting something as a client from the internet, you hook up to a machine. That machine may be a mobile phone also, all right? It is also okay. But you are not browsing the whole mobile phone or machine of the others. You are just browsing one folder inside. Now this is folder. This one here, we call it directory, actually it means folder. You're browsing one folder there, and in the folder they may have a lot of files, and then you may be browsing only one file. So this is folder, and this is file. F-I-L-E, file. Sorry, file. I may be watching YouTube in a particular directory, that means a folder, for a particular MP3, MP4 or AVI or Flash, if they still have it, SWF, right? Depending on what you're watching, right? Or Qt, right? Maybe you're listening to music and that will be MP3, maybe RA or RAM, things like that. You are reading a website, that would be HTML, ASP, PHP, right? All those stuff, right? So you just actually read one file at one time, no matter how powerful your computer is, no matter how many tabs, how many windows you open, but every time you just get one actually, but not the whole directory, not the whole machine of the others sharing with you. Remember that, please. Now, this World Wide Web is particularly worth noticing because it's used media allowing all sense of stimulation to us available with color, with sound, with moving picture, right? And this is HTML. HTML hypertext markup language is actually features with all those multimedia and things, and it's very popular because it's very easy to use. We call this a tag language. You just have to learn a few simple, special word. Those are the tags here, and then you know how to write it right away. And you follow the way they write something, and then you can have the web page just like you're writing in the Word document. Right now, no one bother learning it actually, unless you are working as a programmer, because most of the word processor we have in the world, no matter you're using Page in iOS or Mac OS, or you're using Microsoft Word, they can convert to that HTML very easily. You don't have to learn it actually, right? And yeah, let's take a look at how we get connected. Well, this one is a bit old, to be honest. It's a bit old, all right? We now actually, how do we go connected right now? If we take a look at this list here, we are now actually here using fiber optic in Hong Kong here. Most houses, most domestic or even commercial company, we communicate by means of high fiber optics, all right? Fiber optic. You may be using services from Vodafone 3 or HK broadband, all right, they all basically use Wi-Fi, fiber optics to connect you in a point-to-point manner. That means in a dedicated, specific manner. At some company would want to save costs, and then they would use some high-speed copper wire, and that would be T1, T3. T1, T3 actually, most of them are copper wire. One of the key things about that is T1 and T3 can branch out into smaller bandwidth little line, so you can branch without using any router at all, right? So make your internet connection dividable. In the older day, we have digital subscriber line, right? Now that's the time when most of the communication use copper wire. And that time, because most people download more than upload, so they have two ways of communicating. One is ADSL and one is SDSL, right? ADSL is the first happening because most people download more than upload in the past. That's about 15 years ago, right? Gradually, you find that people would upload something and share, and that's why they would have SDSL, that means symmetric. So upload and download have the same speed, right? And then they come up to higher speed DSL with download and upload also having a very fast speed, about 100 meters per second. Now, even over time, that's about 30 years ago, people go online and then they would let it go from one particular building and get to the internet, and that would be cable modem. We still have cable TV right now. This is actually the predecessor of that, all right? But now we no longer use it because it's actually very slow. It's just about a few hundred kb per second, so it's really, really slow. If you have really no money, but you want to go online, actually, you can also use electrical socket on the wall to go online. Our electrical line at home can actually carry signal, but it's also very slow. So if you're in, say, country like Indonesia, maybe sometimes they don't have internet connection, but you need to go online, you probably have to get an adapter and make use of the electrical wire to go online. So this is another way to go online, pretty slow, all right? Because that would only be about 60 or 80 kilobyte per second. That's really, really slow, actually. Now, another case that we have to know when we talk about connection is sometimes people stop you by the street and ask you if you like to subscribe to their service, and they provide you 1 gigabyte per second online, unlimited, right? Something like that. What else would they say? And yeah, they say it's very fast, 1 giga, right, per second, something like that. So what exactly does that mean? It actually means the speed from your home to the Chinese University of Hong Kong. That's the speed they're talking about. Because most internet connection in Hong Kong actually would go to the Chinese University of Hong Kong. There is called the Internet Exchange Hub. And from that exchange hub, we go out to the world, okay? So when people sell you with the package on the street, what they're saying is only from your home to the Hong Kong Internet Exchange, we call it the Hong Kong Internet Exchange, which is actually a group of servers located in the Chinese University of Hong Kong, all right? So make sure you know that. Now, once you go through the Chinese University of Hong Kong Internet Exchange, what speed you experience is no longer how fast you are going online. It's all dependent on the server response. If the server that you are talking about is real slow, even you have fast connection, you have to wait. You see what I mean? All right, this part it may be a little bit complicated. Let me say those words one more time in Cantonese. 你喺條街度咧，人哋兜你買嘢咧，買嗰啲咩 internet 嘅 速度呢，就係由你個屋企去到香港中文大學嗰個互聯網資訊交匯中心嗰個位置咁短嘅距離嘅啫。咁佢可能話俾你聽1G上網都好呢，就你嗰度去到香港中文大學就1G咯。但係出咗街之後去到人哋個國家個網站呢，究竟幾快呢？就同你嘅速度係冇關嘅，因為人哋個 server 慢到飛起呢，你就會慢到飛起等佢噶啦。你而家明唔明啊？Okay, so that's the situation. I hope you kind of realize next time when you have to think about a plan, people selling you in the street, okay, think this very seriously. Sometimes if the server that you're connecting is always all that slow, maybe you don't need to be 1 gigabyte per second plan, you still have to have a decent speed. All right, now to get ourselves ready for World Wide Web, we have to set up the client ready so that it can go smoothly. And of course, for World Wide Web, we need the browser. The browser is normally called navigation tools. And because we know the World Wide Web has so many things there, it's like a sea of information. To find something out of it is nearly impossible. So we have to know how to search things out of it by means of search engines or directories. All right. So those are the setup allowing you to browse the web, or we call it surf the web easily. Navigation tools is about browser, right? Browser actually. That we say browser, right? Browser. For browser here, we have actually two big types. One is text browser. One is the browser you and I use, graphical. Text browser. Who will be using text browser? Can you guess? We still have that kind of person in the city. There are a bunch of unfortunate people who cannot see. The blind. The blind people don't think that they're blind, that they don't go online, okay? They go online, but they don't see the online stuff. They listen, they hear things there. Okay? So they use browser. This is the text browser they use. The text browser would connect to a speaker that would talk about the web. So they know the web information, just like you and me. Okay? So text browsers do have a big market in society. And of course, we more concentrate on graphical, because we see, we have eye and sense, enjoy the color, the moving picture over there. And among the popular browser we have in the world, we have Microsoft Edge, or before we called it Internet Explorer. We have Firefox, we have Chrome, we have Safari. So among them, which one, you may ask, is the safest? Anybody, any idea? Among the four of them? If you think Microsoft, you definitely get a wrong answer. This is the safest. Safari, so far, is the safest, right? Because the way they construct is actually unknown to the outside world, right? That makes it actually the safest so far. And Apple also is quite famous right now in the world for keeping information encrypted. So if you are to do some online trade and you want to do it in a secure manner, we always recommend people use Safari. But not a lot of service support it because it has a very high demand in communication. If you want to communicate on the internet and enjoy the fastest speed, okay, you go for Chrome. Now, Chrome is fastest, but it's not very safe, I'm telling you, because Chrome is actually open source. In other words, if you study computer science, you know how to do programming, you can take a look at the Chrome and see what's the problem there. You can pick that problem out and attack that, and that Chrome browser will break down very easily. And make use of that, you can break the other people using it, and then you get the information of the others. Of course, that's illegal, but that's possible also, all right? So Chrome is something like that. A lot of people use it when they need to browse things fast. They use it. So Firefox is somewhere in between. They are not very fast, all right? They are not very safe either. It's somewhere in between. And Firefox, part of it is actually also open source, so that makes it not very safe. In our school, in academic field, they use Firefox quite a lot. Microsoft Edge, well, is actually the slowest in the market. But it is something that you just cannot say you don't want, and then you can have it, and you can leave it aside. No, because whenever you use Windows system, this is actually the browser that they would force you to install no matter what, right? Now, no matter what browser you're using, they all share the features of they would have menu, right? History function, bookmarking, preference function, and of course, no matter what browser it is, you can enjoy multimedia in it. That means text, image, moving picture, static picture, right? That's multimedia. The future of multimedia, actually, add one more thing there. If you take a look at your own face, you're going to know it. It's smell, all right? Right now on the internet, we still don't have any imitation of that, but that's actually the next generation of internet multimedia experience. Because with smell there, we more or less be more into the environment, right? That's also true. Now, once you get the browser set up, that's the navigation set up properly, we can consider the next necessary setup for us to go around, and that would be search engine and service directory here. Now these two are actually the same thing, and we take a break for 10 minutes first, and then we come back and we talk more about that. So let's stop here for the time being. 好，等我停一陣先。